Hello guys, welcome back to my YouTube channel. So today we are going to solve day 4 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 1930, unique length 3 palindromic subsequences. So let's read the problem statement first. We have given a string S. We have to return the number of unique palindromes of length 3 that are a subsequence of S. Note that even if there are multiple ways to obtain the same subsequence, it is still only counted one. Okay, so here see A, B and this A. Okay, and here this A, B and this A. Okay, so both are palindromic, right? And there are two ways to get this A, B, but we are just going to make only one count. A palindrome is a string that reads the same forwards and backwards. Okay, so this we already know, right? What is palindrome? A subsequence of a string is a new string generated from the original string with some characters, can be none, deleted without changing the relative order of the remaining characters. Okay, for example, ACE is subsequence of ABCDE. Okay, so we are not deleting any characters, right? So here see A, C and E is a subsequence of A, B, C, D, E. Okay, so now let's understand this with an example. Okay, so palindromic size is fixed, right? Size is fixed, always 3, right? So, and you know what is palindrome, right? A palindrome is a string that reads same forwards and backwards. Okay, so that simply means that the character at this index should be matching with the character at this index. Okay, so here let's suppose if I have A here, then it should be A here, and in the mid index we can have any value. Okay, we can have A, we can have B, we can have C, we can have D to Z. Okay, we can have anything here, okay, in the mid. So all these are going to be nothing but my palindromes, right? So here we have to find the unique palindromes of length 3. Okay, so length 3, right? So that simply means that this value should be matching with this value, and inside this we can have anything, right? So if this is the case, then that simply means that we have a palindrome of length 3, right? So here in this problem, if you see, the three palindromic subsequences of length 3 are A, B, A. Okay, A, B and A. Then we have this A and A. Okay, A and A. And then we have ACA. Okay, ACA. So if you see here, see this character is matching with this character, and inside this we have A. This character is matching with this character, and inside this we have A. This character is matching with this character, and inside it we have C. Okay, so these are the three palindromes that we are getting here. Okay, right? And we don't need to count the duplicate ones, right? Okay, so this is given the problem statements. Okay, so even if there are multiple ways to obtain the same subsequence, it is still only counted one. Okay, so now here let's suppose I have a string. Okay, so I have a string, let's say A, then B, then we have C, Z, D, A, F and A. Okay, let's suppose I have this string. Okay, so now in this string we are finding the palindrome of length 3. Okay, so see the starting position of this string. Okay, here it is A, and now I'm just going to calculate the end position in which I have this character A. Okay, so here A is here and A is here. Okay, so let's pick the last one. Okay, last position of this A. Okay, so last position of this A in this particular string is here. Okay, so this is nothing but my first index at which I have A, right? So I can simply say that this is nothing but my I. Okay, let's say, so I is the index in which I have character A. Okay, first time, and let's say J is the index at which I have the same character at the last index. Okay, at the last index. Okay, last time when I see this a, so it is a here. Okay, so this is the index. Okay, so now let's keep these two fixed. Okay, so we have to find the palindrome of length 3 now. Let's keep these two fixed now. Okay, now inside this we can put any character, right? We can put anything inside this. We can have this b, right? We can have this b, or we can have this c here, right? Or we can have z here. Okay, and here if there are duplicates, let's say here two d's are there. Okay, so we have to just keep one d na, not two d's here. We don't have to count a d and a this d and a. Okay, we have to just count any one, right? So here 1d. Okay, I can keep. Here we can have a. Okay, here we can have f. Okay, so here how many different substrings I'm getting here, different palindromes I'm getting here? So 1 2 3 4 5 6. Okay, 6 we are getting. Okay, so here I keep this fixed, and we are getting 6. Okay, and 6 is nothing but this 1 2 3. Okay, so two d's are same now, same characters, so we have to keep the unique. Okay, so here this 5 and this 6. Okay, so here we are just keeping the unique. So what I'm going to do, from index I plus 1 until index j minus 1, I will just find out the unique characters in between. So that simply means that I'm going to use set, right? So using set, because my set is going to contain only unique characters, right? It doesn't contain duplicate characters, right? So I'm going to use set, and in set I'm just going to add all the different characters that I have. So I have 6 different characters, so it is going to give me total 6 different permutations, right? So 6 different palindromes, right? 6 different combinations, right? So all these are palindromes, right? a b a c a z a, right? So I'm just going to add this 6 in my result. Okay, in my result. Then after that I'm going to search for the b. Okay, so I move to this b. Okay, and this b first time it is occurring here, and where is b occurring last time? So it is occurring nowhere. Okay, so my I and j both are going to be at same position. Okay, so now if I do I plus 1, okay, here I plus 1, and for this I do j minus 1, so my I plus 1 becomes greater than j minus 1. Okay, that simply means that they are crossing each other. That simply means that they are crossing each other. So if they are crossing each other, so we don't have anything to add. Okay, so it is not forming any palindrome here, right? So this is the first way. So this way, this approach is nothing but count letters in between. Okay, so what I'm going to do, this is my string. Okay, in this string I'm just going to find all the unique characters I have. So I have a b and c. Okay, these are the unique characters I have. Okay, I'm going to add these characters in one set. Okay, a b c. Okay, unique. Then after that I'm just going to iterate over all these characters one by one. Okay, so first I'm iterating over this a. Okay, and then I'm going to search for the position of a, first position and the last position of this a. So first position of this a is at 0, and the last position of this a is at, okay, first position of a, last position of a. So last position of a is at 0 1 2 3 4 index. Okay, so now from I plus 1, that simply is 1, j minus 1, that simply is 3. Okay, so 1 2 3 I will just find out the different characters. Okay, so what are different characters between 1 to 3 index? So a b c okay, all are different. Okay, so here in the result I'm going to add 3. Okay, 3 plus. Now I will iterate over this b. So I'm going to find the first and last position of b. So both are same, right? So b is first position of b is 2. Okay, and last position of b is 2. Okay, so here my I is going to be at 3 and j is going to be at 2. Okay, so that simply they crossed each other. Okay, I becomes greater than j. Okay, so in that case I'm not going to add anything. Okay, 0. Then for this c, so first and last position both are same. Okay, so I and j are going to cross each other without finding any valid 3 side palindrome, right? So here 0, so overall result is going to be 3 only. Okay, so now let's write the code. Okay, then after that I will explain approach 2, which is going to nothing but pre-compute the first and last indices. Okay, but first let's write the code for count letters in between. Okay, approach. So here what you need to do, let's create one set of characters. Let me just zoom it. Name it as letter, new hash set. Okay, now just iterate over all the characters. Okay, for character C in my string to char array. Okay, and here just add the letters. Okay, letters dot add C. Okay, so I have added all the unique characters, right, in my letter set. All right, now create one variable answer, set it to 0. Okay, and this is what we are going to return in the end. Now just iterate over all the characters in my letter one by one. Okay, so here character letter in letters. Okay, and here now we have to find the first and last index. Okay, so initially set I is equal to -1 and j equal to 0. Okay, initializing like this. Okay, so I is equal to -1, that is nothing but my start, and j is not 0, nothing but my last. Okay, last index. Okay, initially. So now we are just going to iterate over all the characters in my string s. Okay, so here run one loop, int k is equal to 0, k is less than s dot length, and here k plus plus. Okay, now here just check if s dot character at index I, okay, index k. Okay, so if it is equal to letter. Okay, so if it is matching with the letter, then here inside this if condition, if I is equal to -1. Okay, so in the starting my I is equal to -1, right, in the starting. So if that is the case, then I'm just going to update the I to k. Okay, so that is just going to update the my first index position. Okay, so this if condition is just used to update the starting position. Okay, so initially my I is equal to -1. Okay, in the start. Okay, so now if my I is equal to -1, that simply means that I'm going to update I is equal to k to the starting position. Okay, now after this, okay, so initially I have found this, I'm searching for this a, initially I have found this a at this 0 index. Okay, so I have updated I to 0. Okay, now next time whenever I encounter j, I'm just going to update the j position. Okay, so initially when my I is equal to 0, here I'm going to set j is equal to 0. Then again I have found this a here, so I'm just going to update j to 1. Again I have found a here, I'm just going to update j to 4. Okay, there is no change here in I. Okay, so that is by this if condition. Okay, and j every time I'm updating it to k. Okay, so in this way j is always going to get the last index where this character is available. Okay, where this letter is available. All right, so this is done. Okay, now in between we have to search, right, and in between if I'm searching, so I'm searching for the unique characters, right, so we have to create one set. Okay, new hash set. Okay, so here let's create that set of character between, okay, new hash set. All right, and here just run one loop. Okay, so here I have told you that we have to run the loop from I plus 1. Okay, and k should be less than j. Okay, j index, so j minus 1 until, right, and k plus 1, right, and here inside this in the my between, okay, in this between variable, okay, between set, I'm just going to add, but I'm going to add the characters. Okay, so as put character at index k. Okay, so here whatever the size of this between, okay, I'm just going to add that to my answer every time. Okay, answer is equal to answer plus between dot size. All right, and now in the end we have to just simply return answer. That's it. Okay, so this is nothing but my approach one, that is nothing but count letters in between. Okay, so let's see what are the issues we are getting here. Okay, so let's update these two letters, and here line number, okay, here for int it should be k now. Okay, so all the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? And the time complexity is going to be of n for this one. The reason is very simple. See here. So we are adding all the unique characters in my letters. Okay. So we have only lowercase English letters in my string, right? So we have just 26 letters, right? So maximum time this loop is going to run just 26 times, right? We have just 26 unique letters in our alphabet series, right, from A to Z, right? So 26, and this, let's suppose my string length is n. Okay, so 26 into n, so we can say that it is just of n, right? Time complexity. So that is why the time complexity for this problem is going to be of n. Okay, so now let's move to the approach number 2. Okay, so approach 2 is also very similar, but in that approach we are just going to create two arrays, and in those arrays I'm just going to store the first position at which that character appears and the last position at which that particular character appears. Okay, so let me just reset it. All right, so now let's move to the approach 2. Okay, so in approach 2 what you need to do, okay, so the name of approach 2 is nothing but pre-compute first and last indices. Okay, so you are going to create one first index, okay, and you are going to create one last index. Okay, and the size is going to be 26. Okay, so at 0 index we are just going to store the A first position, at 1 index we have to store the B first position, at 2 index we are just going to store C's, okay, and here D's, okay, and 3, okay, and here at 25 index I'm going to store Z. Okay, okay, so this is going to be my first and last. Okay, so now let's take the same example here, A B C A. Okay, A B C A. Okay, so here this is my string, right? So this is nothing but index 0, index 1, index 2, index 3, index 4. Okay, so now here initially do one thing. Let's just fill this my first array with the -1. Okay, initially, oh, this value with the -1. Okay, and let it be 0. Okay, in the starting it is 0 only, nothing. I'm not going to fill anything here. Okay, now I'm just going to iterate over this string one by one. Okay, and here I'm going to check if this A is appearing first time or last time. Okay, so right now this A is appearing for first time. Okay, at which index? 0. So I'm going to update it to 0. Okay, and side by side update this as well 0. Okay, so this I'm just going to update only for first time. Okay, if this character is appearing first time. So here after that I move to this A. Okay, so this A is appearing for the first time. No, it is not appearing for the first time. Okay, if it is appearing for first time, then there should be -1 here. Okay, but right now there is not -1 but 0 here. So that simply means that it already appeared in the past. Okay, so here A is 1, so in the last I'm just going to update it to 1. Okay, so here I have added 1. Now this B, okay, I move to this B is appearing at 2 first time. Okay, why first time? Because here it is -1 right now, so here I'm going to add 2. Okay, and here also I have to update B to 2. Okay, last I'm updating every time. Then I move to C is appearing at 3. Okay, for first time, because here it is -1, so here I'm just going to add 3. Okay, and here also I'm going to add 3. Then A is appearing at 4. Okay, so here it is appearing for first time. No, it is 0 here. Okay, so here I have to update 4. All right, so this is the first thing that we have to do. Okay, then once this is done, okay, once this is done, then create one variable answer. Okay, in this I'm going to store the answer. Okay, then iterate over all these. Okay, over all these indexes in my first. Okay, over all these 25 26 indexes. Okay, 25 indexes starting from 0. So if it is -1 here in my first, then just continue. Don't check for the last one. Okay, if my first index value is -1, so here it is -1 everywhere, right? -1. So I'm not going to check all these things, so I have to check just this three part. Okay, here. So if it is not -1, then check the characters in my string between 0 plus 1 is 1 and 4 minus 1 is 3. Okay, 1 and 2 3. So 1 2 3, check all the unique indexes, unique characters. Okay, so here 3, so add that 3 here. 2 to 2, okay, that simply means here 3 and 2. Okay, it doesn't make any sense. 3 to 2. Okay, it's like this. Okay, it doesn't make any sense. Okay, so both are crossing each other, right? So if here both are same, okay, so here that's simply 4 to 2. Okay, that doesn't make any sense. Okay, 3 plus 1 4, 3 minus 1 2. Okay, 2 plus 1 3, 2 minus 1 1. Okay, 3 to 1, it doesn't make any sense. Okay, crossing each other, right? Crossing each other, so it doesn't make any sense. Okay, so only 3 is going to be output. Okay, so simple, similar to our approach one. Okay, but here we are just going to pre-compute first and last indices. Okay, that's what we are doing here. Okay, so now let's write the code is also going to be very simple for this one, similar to what we did in approach one. Okay, so int first is equal to new int 26. Okay, and same way copy this, paste it here, and let's name it as last. Okay, and now just fill the first. Okay, so arrays dot fill first with -1. Okay, then just iterate over my string for int I is equal to 0, I is less than s dot length I plus plus, and here inside this int cur is equal to s dot char at index I minus a. Okay, so it is just going to give me the current index. Okay, where we have to check. So if first cur, okay, so if it is equal to -1, that simply means that this character is appearing for the very first time. Okay, so in that case we have to just update my first of cur with I value, right? And always I'm just going to update my last of cur with I. Okay, so this is what we have to do always, right? Last of cur with I. Okay, in this way we are just going to add the last position. Okay, get the last index where that particular character appears. Then same int as is equal to 0. Okay, then just iterate over 26 indexes of first. Okay, so int I is equal to 0 and I is less than 26. Okay, I plus plus, and here just check. Okay, if first of I, okay, is equal to -1, all right, then we have to simply continue. Okay, then we don't need to check, but otherwise we have to just find the number of unique characters in between. Okay, so set of here same code that we are written previously. Okay, in approach one, character, all right, here name it as between, right, and here no hash set. Okay, and then just run one loop for int j is equal to first of I. Okay, in this add 1, right, and here j is less than last of I. Okay, and here we have to just increment j, and here in the between set we have to just add s dot char at particular index j. Okay, and once this is done, this is very similar to what we did in approach one, right? In answer we have to just add this. Okay, between dot size. Okay, and in the end just return answer. That's it. Okay, answer. Okay, so now let's run and see if there are any code issues. So all the test cases has been accepted. Okay, and for this part also the time capacity is going to be of n, right? Here we are running this loop for of n time, and here we are running this for 26 times. Okay, so of 26, okay, here and here also we are just iterating in between indexes. Okay, so overall time capacity I'm just going to say it is going to be of n only. Okay, so now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand both the approaches, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.